You know from reading the book that a function is a set of ordered pairs. I've written a couple of sets of ordered pairs over here on the board, and what we want to do is look and see if we can identify which ones are functions and which ones aren't. My first set of ordered pairs looks like this: 7, -1, 3, -1, and 7, 4. Now, we see that we have two different ordered pairs with the same first coordinate. That means that I have two different values of y paired with the same value of x. That means that this is not a function. So the restriction is this: any set of ordered pairs in which no two different ordered pairs have the same first coordinate, that's a function. That's the same as saying a function is a rule that pairs elements in the domain with elements in the range such that no two elements in the range come from more than one element in the domain. Let's look at our second set of ordered pairs. 4, 1, 1, 4, -1, -4. You can see I have three ordered pairs here. They all have different first coordinates, so this is a function. Now the domain is the set of all first coordinates. So in this case, the domain is the set 4, 1, -1. So 4, 1, -1, that's the domain. The range is the set of all second coordinates. So that will be 1, 4, -4. Now, we can also, with this, use some function notation since this is a function, and if we were to say this is the function, let's say f, then we can say that f of 4 is equal to 1. That is, f of 4 is equal to 1. F of 1 is equal to 4, because when x is 1, y is 4. And f of -1 is -4. F of -1 is equal to -4 because when x is -1, y is equal to -4. So I can even use function notation like this when I have a set of ordered pairs for my function. Now, what about if we have the graph of a relation? Can we tell from the graph whether that relation is also a function or not? And the answer is yes. For problem number 3, I've written this graph, and I want to know, is this the graph of a function? Well, if no vertical line can be found that would cross the graph in more than one spot, then I have the graph of a function. And as you can see, no matter where I draw a vertical line here, it's only going to cross this graph in one place. Then I know that I have the graph of a function. If, on the other hand, I can find a vertical line that crosses the graph in more than one spot, then I know the graph is not the graph of a function. Problem number 4, you can see I have this curve right here, and obviously this is not going to be a function because there's a vertical line that crosses there, there, and there. That would give me 3 different points with the same first coordinates. So I wouldn't have a set of ordered pairs in which no two different ordered pairs have the same first coordinate. Anyways, there's a quick look at some of the ideas associated with functions.